Hello, my name is Ashley Crane and I'm the Sales Manager for Quantum Design UK and Ireland. It's my pleasure today to introduce Keela from Specim, who will talk to you about the portable, handheld, hyperspectral imaging camera, the Specim IQ. But first a word about quantum design. We're a global lab equipment manufacturer, but also a hybrid scientific equipment distributor with subsidiaries in every major technological centre around the world. We've been in business for 35 plus years and have a lot of highly experienced and knowledgeable people, and we're eager to know more about how we can help you. But without further ado, here's Keela about the Specim IQ.
Hi, and welcome to the third video of the Specim IQ tutorial series. I'm Keela, and in this tutorial we will go through the basic data recording flow with the Specim IQ. Let's get started. When using the Specim IQ for hyperspectral measurements, you'll need the device itself, a memory card, a charged battery, the white reference panel, and a tripod. When making the measurements indoors, you will also need some illumination. When making the measurements outdoors, you can in most cases rely on sunlight. Before powering on the Specim IQ, place the charged battery and the memory card inside the device. You can find slots for both under the battery compartment door. You can also find instructions for installing both in the correct way. Since a hyperspectral camera is slower in capturing the image than a normal camera, it is always recommended to use the Specim IQ on a tripod to ensure good image quality. Once you are ready to make your measurements, remove the lens cap and power on the IQ as shown in the previous tutorial. Now that the device is ready, let's move on to making the measurements. For this tutorial, we've selected a collection of apples as our sample. Point the camera to the target using the viewfinder feed. Before starting the measurements, make sure to set up your white reference and the illumination. Both of these are crucial details in making a spectral recording successful. Due to this, please see our tutorials on these topics. For now, we will focus on the basic usage and continue with this setup. Place the white reference panel next to your target. After turning on the illumination, we will select the white reference mode on the device itself. Select the simultaneous white reference. This means that the white reference panel has to be imaged in the same spectral image as the actual target. This is the easiest and most straightforward way of using white references. We will cover the other white reference modes in another tutorial. Position your camera so that the target and the white reference panel are inside the rectangle in the middle of the viewfinder view. After this has been done, half press the shutter button to enter the data recording settings. Once you enter the data recording settings, you will see an additional square in the middle of the view. The feed in this square originates from the focus camera, which is used to focus the spectral camera and help align the images correctly vertically. You can zoom into the square by pressing Custom 3 or by using the touchscreen. When you rotate the foreobjective, you can monitor the change in focus on this square. To help you focus the camera, the Specim IQ has a feature called focus peaking. This looks for areas in the image that are in focus and gives them an orange edge. You can toggle the focus peaking on and off from Custom 2. It's your personal preference whether you wish to use the focus peaking or not. Next, you may notice that the image on the smaller focus screen and the image in the background are not vertically aligned. This is caused by the different placements of the viewfinder and focus cameras, which causes a parallax effect. This means that depending on the distance from the device to the target, the two images may be vertically misaligned. The Specim IQ will try to automatically correct this effect but sometimes you may need to fine-tune it manually. To do this, press and hold Custom 4 and use the up and down navigation keys to align the images. You can also do this by using the touchscreen. Now that the images are correctly aligned, let's take a look at the integration time. The Specim IQ will use the viewfinder camera to evaluate the illumination conditions and adjust the integration time automatically. You can see the current integration time on the top left corner. This is a time taken to scan a single line, which is also known as a frame. Below this value, you can see the total recording time, which is the time it takes to scan the whole data cube using the set integration time. You can adjust the integration time by using the up and down navigation keys or by using the slider on the touchscreen. The green area on the bar is the calculated optimal integration time for the current illumination conditions. If you want to reset your manually adjusted integration time, you can do this by half pressing the shutter button. If so wanted, you can also lock the integration time by pressing Custom 1. This prevents the Specim IQ from automatically recalculating the integration time between datasets. You can unlock the integration time by pressing Custom 1 again. Once we have set the integration time, we can enter the data recording mode by fully pressing the shutter button. You can monitor the progress of the data recording on the screen. After the recording is completed, the Quick Data Validation view opens. In this view, you can check the data quality from the image preview and from the maximum and minimum intensity histograms. If the top histogram is highlighted in blue, it means that at least part of your dataset is underexposed. If the top histogram is highlighted in red, it means that at least part of your data is overexposed. Overexposure will be shown on the image preview as a blinking red color. If you are happy with the result, you can select Keep by pressing the Set menu button or by selecting it on the touchscreen. If this was an actual data recording, I would repeat the measurement with a higher integration time to obtain better exposure. For these tutorial purposes, this data is perfectly fine, so we shall select Keep. Once the Quick Data Validation view is accepted, the next step in the workflow is the Reflectance transformation. To do this, the device needs information about the used white reference. In this case, we were using simultaneous white reference, so we need to select the area of the white reference tile from the image. On the white reference selection, we first need to highlight the white area. This is done by adjusting the intensity threshold value by using the slider on the touchscreen or by using the navigation buttons. Adjust the intensity slider until the white reference panel is flashing white and gray. You can then select the area by pressing it on the touchscreen. After confirming that the correct area is selected, press Set to accept the selection. The device will then use the selected white reference to perform the reflectance transformation. This was the full recording cycle using the default recording mode. In the next tutorial, we will see how you can study the data and edit the dataset information directly on the device. If you found this video useful, do give it a like, and please subscribe to the Specim Spectral YouTube channel to follow our tutorial series on the Specim IQ. See you in the next video.